join. Andy is going to do a demo today.
I can
And
always
Gijs,
do a
I don't know if
demo as
you,
well.
is there anything you want to demo, Gijs?
Yeah, sure. I have 3. I can demo.
Okay.
I think I have 3 actually.
I switched audio. Is this still working?
Yes.
Well, glad you said something because that's still coming through my speakers. I'll be right back.
All right. Let's give another minute or two, then we can get started. It's been recorded anyways.
Okay, testing again.
Yes.
Great, there we go.
All right. Well, Gijs, you want to start?
Yeah, sure. I can start. Let me grab my developer box. No, that's not a good one. Let me. This should be the one. Is my screen visible?
We see VS Code.
Nice. All right. I'm not sure if I demoed this one. Maybe probably Andy's demo is going to be a follow up on this one. But I think I demoed this during the work group meeting. But it's on the Visual Studio Code extension that I created to enhance the authoring experience of configuration document in Visual Studio Code. So if you already have like the schema here, I think Mike created some excellent documentation how to get this enabled using the settings from Visual Studio Code. But whenever you're trying to search for resources, I now have my extension enabled as well. So you get the IntelliSense of available resources, and those are both the comment-based DSC resources and the ones through the adapter itself. And whenever you want to see the properties, you can either do the required one or you can get the wall set, and then, well, you have all the properties that come from the resource itself. So if anyone want to try it out, can find it in the marketplace. I published it there. So
Cool.
I think for my second demo, this one is maybe interesting. I was experimenting to convert MOV to a direct configuration document that the DSC V3 engine could get. So I created a small command. So if I do this, for example, so I got my winget MOV that I just created from the PowerShell design state configuration. So whenever I'm running this, you can see, hey, I'm getting back a valid V3 format, right? And if you combine that with a extension itself, so I created a small wrapper around this command actually. So and I now try to run it through the engine. And hopefully it's going to return something.
There's always the risk of a live demo.
Always. And there you go. So I'm off to V3.
Do you have a sense of how much of the MOF syntax you have covered?
Ooh, that's a good one. I try to map most of them versus at least the schema from V3. I also got the depends on working, but like parameters and stuff, I'm not sure.
Very cool.
Yep. And then I guess the last one will be.
Oh, before you move on, how are you doing the MOF parsing?
Come again, Steve?
How are you parsing the MOF?
With a library.
Is this like a community library or talking about the Microsoft one?
It's a NuGet library. It's
Okay.
an open source one. I think it's called what it was called, the Kingsman MOF. I can paste it in the chat.
Oh, I'm just curious. Okay.
Yeah.
Cool. Very good.
Yeah. And then I guess the last one will be so whenever you're doing things to the adapter, the performance itself and the schema validation is not quite ready yet. So, for example, you can see here we have the Windows settings one from the Winget team. So you also saw in the module itself a command a new DSC resource manifest from class. So this creates a resource manifest from a class-based DSC resource. So this is the actual command, and I also included a generate resource script. So what this actually does is it creates a small wrapper script itself and also the resource manifest in that particular location. And then with the extension itself, so whenever I'm now trying to list it out, you can see the resource now participating as a first class citizen itself. So, and I'm now trying to ask the schema for it. I'm getting back the details, and then I can also execute it directly just as a comment-based DSC resource. And what it actually just does behind the scene, it dumps in the resource manifest in the known PowerShell module paths. And the small wrapper script, it's just a small tiny wrapper what's based on the PowerShell adapters itself. So that's it.
Hey, Gijs.
Yo.
How are you generating the schema?
I'm reading everything to the abstract syntax tree, so I'm trying to get all the properties from the class-based DSC resource.
Okay, so you're doing it basically yourself, right? You just parse the AST and then you generate the equivalent JSON schema?
Exactly, yeah.
Okay.
But that's it.
That was very cool. I think once I get the my PR in, which is to handle the streams, because I wouldn't recommend you do any PRs that work against the adapter until that gets in. Otherwise, you're gonna have a huge merge conflict later. Maybe you can consider doing the schema generation in the adapter.
I'll think about it.
Okay, think about it. All right, Andy, do you want to do your demo?
Yeah, I'd love to. So this is I'm going to say it's the long-awaited DSC extension for Bicep. I'm going to start by just sharing a repo that has the examples I'm going to be demonstrating today, especially because they are now actually usable, as in I have a copy of the extension on a public ACR, so you can just run them, minus the fact that you need a dev build of DSC. So as soon as we have the new update of DSC out, you could just install a pre-release of DSC and then run these demos. And these demos are, let me get this screen sharing here. We've got a VS Code visible on the screen.
Yeah, markdown file.
Fantastic. So at a high level, what we've done here is written a DSC extension for Bicep, and I'm saying that in that particular order because if you know what Bicep is, it is both a declarative syntax language and also a resource orchestrator. It is the Azure resource orchestration engine, and for a long time that really meant that like it dealt with Azure ARM endpoints like remote RPs and stuff, and a lot of work was done by the Bicep team to actually kind of bring that orchestration sort of in-house into Bicep itself. And this resulted in what they like to call the like Bicep local deploy, the local deploy experimental feature, which is the one piece that we will be enabling. If you are writing a Bicep file and you want to use this DSC extension, you enable the local deploy experimental feature. Now, don't be scared of them saying that is experimental. They have fully committed to that. That is out. It is in use, not just by us. They have lots of examples. It is working to get into production. We're kind of one of the partners using this local deploy feature. And what this means is that like Bicep is actually just going to do all of its orchestration of some arbitrary set of resources by itself, by the little app that it is. It's not calling out to Azure. We've kind of removed Azure from the picture and allowed Bicep to understand, hey, you've got resources in a file, let me orchestrate them. And why this is important is, well, DSC is also a bunch of resources. The DSC CLI is a resource orchestrator in and of itself, but there's also DSC lib, which is, I'm gonna just jump into a little bit of code to kind of show that it is also just a way to call, if you're talking about DSC, the library, like set, like there's a bunch of invocations that map the same way of you want to set a resource or create a resource or get a resource. And that's actually at like a very high level where we're integrating. The Bicep local deploy feature defines a set of gRPC protocols, remote procedure calls. So there's a protobuf file that you can, if you're anyone making a Bicep extension, let me pull up the protobuf here, just because it's kind of interesting. Bicep.proto. This comes from the Bicep project in and of itself. It's saying, hey, you just need to make a gRPC service that responds to these calls of create or update, preview, get, delete, get type files, ping for these resource specifications. And yeah, that's the great news for DSC is well, we kind of map to the same interface. This was a good move early on of DSC being like, well, let's conform to the ARM spec. But like we were conforming to an implementation detail that got us to actually conform to a design spec. So we support in the same set of things. Like if you're familiar with the DSC command line, you call DSC set or get. And underneath the covers, what that's doing after it does its own orchestration, it calls into DSC libs, get or set, that code that I was just looking at. This is Rust code right here. Like I've got a DSC resource inside of DSC right now. This is from that DSC library I'm calling .set. So by creating a small, this is not a big file, a small gRPC server inside of DSC, this turns into a binary called DSC Bicep X. You can see it's in the DSC project itself here. We can actually go ahead and handle all of the calls for any set of resources from Bicep. This is really cool because it lets us do something like this. I'm going to go to this, my lovely demo, and I've kind of demoed the same behaviors because I think it's a really easy to visualize demo, but this is a file called windows.bicep. It is Bicep code. What I've done is say, hey, I'm using the DSC extension with the target scope being local. The only other requirement other than these two lines to orchestrate DSC resources with Bicep is this Bicep config where I've turned on that local deploy and I've said, hey, that DSC extension, you know, that extension DSC line right there, I need to tell you where to get it from. This is the final piece of the puzzle for me that I got going this week is it is available at this URL and Bicep will just automatically restore that for you. So you could actually take this Bicep config file from the example repo and this windows.bicep file. And as long as you've got an up-to-date version of DSC, by that I mean like tip the main because we don't have the changes into the latest pre-release out yet, you can go use these resources. So I've got a bunch of Bicep code written here. I'm going to go ahead and make my screen a little bit bigger. What am I going to do in this demo? Well, I want to change the color theme of windows here, which I'm going to do by using our registry resource. This is the part that I think is really cool. I actually don't know what theme I'm using, dark or light, right now. I've made a little parameter here called dark mode that takes a few options, toggle on or off. And that parameter that's a bicep parameter, right? So if I look at the file that I'm actually going to pass to bicep, it says windows.bicep param. That supports all arbitrary things that bicep supports, because bicep is going to go ahead and take this, so you could have bicep functions in here too. And I'm setting my param dark mode to toggle. And this is my own configuration document, like, right? That's the equivalent over in DSC. This is a configuration document of resources. And if we look, I'm actually going to scroll to the resource. I'm going to use this Microsoft.Windows/registry resource. And I'm actually going to do a get call on it. So like on the command line with DSC, you'd have to go do a DSC get and see what it is. And well, from a configuration document, you're sort of stuck there. But I actually can say, hey, I'm going to use this resource. I'm naming it current registry key. The resource that I'm executing is registry. This existing says, hey, that's a resource that is existing. Do a get call. That's sort of just the bicep equivalent of get. It's put this existing keyword there. And what it does is it goes and finds the resource that matches the inputs. Well, what are those inputs? They're these properties. I really loved what Gijs just showed with IntelliSense, so I'm actually going to go ahead and delete a little bit of this, so that hopefully my IntelliSense lines up, and I could trigger this and say, hey, look at that. It does know for this registry resource that key path is a thing I want to fill out, and that it can take certain things. So I'm going to just go ahead and put back what I deleted there. But there's full IntelliSense for all the resources that it knows about. If I were to have deleted this, I can see that, there's different resources to use. I'm going to fill it out with registry and version. And what is this part of the demo doing? Well, I actually am using bicep code to say, go look at the last part, like last item of the keys array, which is the second thing that I defined here. Grab the path. So this is executable bicep code that's going to go ahead and say, you want that object, and get the path. So I'm filling in path right here, which is also using bicep string interpolation, right? To fill in my prefix. Like, I just kind of try to write this as a piece of reusable code, like as an author of a configuration file. Like, I didn't want to copy paste this whole string over here, so I got to put in my string interpolations, make an array, say, hey, get the path and the name of that last item. Great. When it executes this, it's actually going to go and look up system uses by theme under HKCU software, Microsoft Windows current version, themes personalized, and get the value of it, which is really cool because I'm going to go do something with that value. Current registry key, I'm actually going to pull the value data off of it. And you can see there's full types here. It knows that that's a registry resource. It knows that value data could be any of these types, because that is what is defined for a registry resource. And that I'm actually going to go into it one more time and get a D word. And you can see some of these question marks. If you're not super familiar, this is like null coalescing, because value data could be null. So to satisfy the strict typing that Bicep gives me, I actually have to say, hey, that could be null. And if it is, I'm going to just go ahead and assume that it's 0. And if it's not null, I'm going to get the D word. And then D word itself might have been null. And so I need to null coalesce that again to 0. And actually, finally, just to jump ahead a little bit, well, this could be a negative number, and Bicep typing knows that when I use it to set later, that it needs to be positive. If I took out this call to max, you'll actually see Bicep telling me, by the way, I'm providing a value that might be -1, but I can't do that. It needs to be positive. So, I'm doing the max with 0 to ensure that it's a positive number. So there's really full and complete IntelliSense happening here, but not like just IntelliSense, also the full value of the Bicep typing system. So I go ahead and I get that current value. At that point, I'm talking about a number here. And now I'm doing some more cool Bicep code, like stuff that I don't think you could do in a YAML document. I'm saying, well, hey, if dark mode was the string toggle, I'm using a ternary right here, compare dark mode, the param string that could be off, on, or toggle. If it is toggle, go ahead and execute this bit of code, take the value that I got, add 1 to it and mod it by 2. I'm flipping the bit. That's just, computer sciencey stuff. I'm saying, hey, if it was 0, make it 1. If it was 1, make it 0. I'm toggling, because in the end, when you set those registry keys, they need to be 0 or 1 for dark mode. And if I set it to dark mode, then it needs to be 0, and otherwise it needs to be 1. Just don't worry about it. That's what the registry wants for this. The cool thing is that the dependencies were all automatically figured out because Bicep's a resource orchestrator. It sees that, hey, the next thing that I'm going to do here is a for loop of resources. I'm doing a set. I'm saying, hey, we're using that Microsoft Windows registry resource again, equals, I'm going to set that resource to a bunch of things. And I'm using a for loop here. So for key and keys, keys being that array that I made earlier. So all these registry keys, that's kind of what I'm doing here. Go ahead and set the key path to each one of them and the name to each one of them and that value data that I use. And this is where the dependency resolution is happening. I didn't have to tell it, by the way, I'm going to do this set and it requires this from a Git. It actually sees that, well, I'm doing a set and I'm passing it a value called value data. And value data came from this, on and on and on. It understands that it has to execute the Git first. So it's not that I ordered this first. It actually is doing like the depends on, goes, okay, cool, let me do the Git and then I'll do the sets. And on top of that, when you see this cool little bit here, I have full support of Bicep right here. This doesn't depend on like DSC understanding a for or a copy inside of ARM. DSC in the end just gets calls to do a set. It gets a call to do a Git and then a call to do set, right? It's just getting kind of the high level stuff from Bicep after it's done its orchestration. So DSC is going to see a set of properties and a Git or a set request. And so I can set all of those things. And then the second half of the demo is what to kind of display output. I've got another param called packages. I'm saying that is an array. If I go back to the Bicep param file, I've set it to Microsoft.bicep and git.git. And I'm not doing an install on these. I'm doing a git on them because I put this existing keyword. I can do an install. I actually used a modified version of this demo to set up my work laptop the other day by taking out existing and then just listing all the packages, and it did like the win-git install for me. But I'm going to use that win-git package resource. I'm going to iterate over that array again, and I'm finally going to say, hey, the thing that I got, we're going to do some output. This is a Bicepism. The keyword output says, go display this thing. And what is it? It's an array of data. And what is that array of data? Well, it's the result. It's the resource result. So I'm going to go ahead and actually execute this now. So I'm going to pull up my terminal. These are the only two things. Well, really, the only thing you've got to do is have that Bicep config set like I've set it, which is pointed at the DSC extension and local deploy turned on. And then a Bicep file that says extension DSC and target scope equals local. And finally, a Bicep param that is using the module. You have full module support. You have literally anything that Bicep could have because Bicep is what's parsing the Bicep files. Now I'm going to tell my machine, tell this this process instance where DSC is. In my case, I'm using a debug version. I've got qsource DSC bin debug set, update my path there. Yes, I am being brave about to do a live demo here in a new terminal. And the next thing I'm going to call Bicep local deploy and pass it my Windows param file. And if everything goes right, which I think it will, we'll see my Veeam get toggled, and then we'll see some output of the win-git packages. So go ahead and hit enter here. We've got some orchestration happening. You can see the first thing it did was that current registry resource. It knew it needed to do that before doing the sets, got that value. And then once it did that, it could in parallel do all the sets on those registry keys and do the win-git resources. So there we go. I just flipped that bit on those registry resources. The only thing that DSC ever saw was executions against the DSC library of git and set with full property bags in the name of the resource and the version of the resource. And you can see the output I got for these packages too is kind of what you would expect to see from win-git if you from that win-git resources if you asked it for the properties. That I've got the Microsoft.bicep package and it is installed and its version is 0.42, and same for Git, that it's installed with that version. And that's kind of the demo that all of this works. And the cool thing is you can go run this too with just those steps. So Yeah, I am really happy to get into like what this sort of looks like inside of DSC if people want to see that. I've shared the link to these examples and the file sort of explaining how all of this works. I'd be happy to show more of the IntelliSense and types too if people want to see. But I'll go ahead and pause there because I saw a hand raised and start taking some questions.
Love the demo, Andy. Quick question. Do the user-defined types also work?
Can you tell me exactly like user-defined type?
So, for example, you show the registry one, right? But you can't always see, for example, the available, like the first part. So if you're doing things in the current user, right, like an enum, you can still define it in a user-defined type. Is that also still possible here?
So I'm going to tell you that it's possible. I'm going to tell you that it's not doing it just yet. Right now, the way that I'm setting up types for the IntelliSense is this file that I just opened up. It's a TypeScript script. The README kind of explains what's happening. I run DSC to get all of the manifests for the resources on a machine and then all the types for those resources, right? Like if you did a DSC resource list to get those manifests bits. And there's a processing file, types.ts, that it parses the ASC of those manifests and figures out what the types are. And there's a little library from Bicep that says, hey, let me go make that type. And then under the covers, what's happening is that's getting all filled out into a JSON file that gets published with the extension. So types.json, you can see like any type, like the base types are getting defined here, any array, Boolean, integer. And if I scroll, you'll see like here's the registry type getting defined. Now that's what it's currently doing, but that's not to say that's the only way to do this. That was the first thing I wanted done, was support all of the known types. And so the extension that is published has all the types built into DSC right now on a Windows machine. That is a base setup. And so it also has the winget types because I had winget installed, and therefore when DSC resource list was run, it had the winget types too. But what I want to enable is live typing, as in, hey, when this extension is loaded, can we get types off of the machine? And that's doable. It's just not done. That's part of the proto buff spec here of get type files, that RPC call. I could. It's just, we got to get time for it. In the implementation of this, the Rust server, the extension that gets published, get type files. Type files. Right now, you can see I'm literally saying not implemented yet, but this is implementable. Like when the time it has come to do this, I could certainly implement arbitrary code here to be like, hey, what types are on the user's machine where I'm executing right now? Like where the extension is loaded, which is, when you're writing in the Bicep file, that is actually Bicep in the background going and restoring the extension and loading it and actually running that binary locally. So I could actually do inside that binary anything that I needed to get your types and return it so that it's available in the live IntelliSense. It's just not done yet.
That would be pretty cool. I think on the defined types itself, I pasted a link in there because I think you can still use the Bicep ecosystem to define your own user data type. So you probably get already some IntelliSense there.
Yeah, I bet so. And that's like one of the big things I see like as the next steps for this for me is I want that live typing done, and I want to teach Bicep itself about semantic versioning support. Right now, if you saw, there are versions. If I go back to that Bicep file, the one that gets me, for instance, is the winget package version. Bicep right now just kind of requires that to be the version. If I set this to something else, like 100, it's fine. I've taught it as like I put a fallback type in here and it'll just say, I don't have the types for that, so I'm not going to get the IntelliSense. But as you can literally read it, it won't block the resource from being deployed. So as long as that type is on the system, you can still do it. But this is where it gets a little annoying, right? Because I've published the package with this type in it, which will actually give me like IntelliSense for all the things you could put on the winget package. But when they go and update, you got to change that type and you lose your IntelliSense. And I just want to teach this to do something like this, right, semver, and be like, actually match against whatever type of semver. And that's just work I need to do with the Bicep team to give them semantic version support when using like an extension. So not done yet, but doable and in my plan. That's kind of my two big ticket items I think I want to tackle next is versioning and dynamic types.
Nice. Last question, and then I'm going to give it to Steve. From what Bicep version
please.
can you use local deploy?
All of the latest versions. So I did not execute this against any dev build of Bicep. This is all built into Bicep now. I did have to patch it way back when, but that has been released. So what was that version I've got on my machine? I used Bicep 0.40.2, and that has everything you need.
Cool.
All right. Thanks, Gijs, for the good question. But I wanted to clarify Gijs's question, I believe, which is about types, because I think Andy answered a different question. So I think we're overloading type here in terms of, I think Andy's mostly referring to resource types, meaning resources. And what Gijs was referring to, if you go to the link, is user-defined types, which is more like constraints on like a string or an object and stuff like that. So we also have that support in DSC, but I believe what Gijs you're looking for is because you define it in the Bicep file, then all that should be handled by Bicep itself and not the extension, is my expectation. Because by the time the DSC extension gets called, everything's been resolved.
That is exactly it. And that's actually why you're seeing this version of our experiment. If you've been following along back mid and late last year, we tried just getting ARM out of Bicep, and then we realized and then feeding the ARM over to DSC, and we sort of realized that we were playing both parts. Like if you got ARM straight out of Bicep, nothing was parsed. It was just literally a bunch of function calls and arbitrary properties, and it meant that DSC had to go implement every single function that Bicep ever implemented, and we just kind of realized we were porting what Bicep was already doing, the orchestration, the execution of its own functions, like stuff like the string interpolation, stuff like user-defined types and module support, and like this Bicep param file. And so we took a step back and actually integrated this at like the API layer between DSC lib and Bicep. So if it's supported in Bicep pipes, if you're talking a user-defined type in Bicep that you write in a Bicep file, yep, that's done, fully supported. It's simply because Bicep is what's processing all of that. When you actually execute against DSC, let me go to the set function here, just to really clarify, but to do create or update gets the full spec of properties as after all the resolution has happened. So there's no function calls in there. There's nothing for DSC to actually like interpret or anything. It is just straight up all of the resolved properties, the version and the resource type, and those are passed straight into set on that property. It does, if you are familiar with the DSC code, it pulls up the DSC manager, it finds the DSC resource with the resource type and the version, and then on that resource, it calls .set with these properties. There's nothing in between, like anything that needed to be done is done at that point, which is why like the get and the set sort of work in my example with the registry stuff. There isn't a depends on that's going to DSC. Like DSC kind of has to do that for its own stuff. Like if you're writing a YAML file, you have to set one resource to depend on another, and there's logic in the DSC orchestration engine to handle depends on, but this isn't using any of that. This is only using DSC library. That dependency was handled by Bicep before it got called. So the whole tree of dependencies is resolved, and Bicep just calls these functions inside of DSC lib. Does that make sense?
Let me add on before we get to you, Gijs. Like the thing I want to make clear is that in what Andy's demoing here, DSC exe is effectively playing the role of the old invoke DSC resource commandlet. That's fundamentally it. DSC will continue to evolve as an orchestrator independent of Bicep, but that also means that one of the effects of, how do I put this? Like one of the limitations of what Andy is showing is that what we're not going to support is that you write a Bicep file, you generate the JSON, and you feed that JSON to DSC. Like that's not going to ever work because DSC and Bicep are heading two different directions at this point. So if you want to use Bicep as the orchestrator, then you have to use the DSC extension for Bicep and have Bicep do the orchestration versus DSC. Gijs, go ahead.
And I should unmute the other mic. So I
You're
guess then
unmuted
also
now.
the I guess then the custom functions that are implemented in DSC are defined in here.
Doable. I haven't gotten to it.
Okay.
There are APIs in like Bicep's hey, tell me what your types are library to handle custom functions.
Yep.
I just hadn't done that yet. So I expect that to be doable. It's just not done yet.
Okay. I was just curious if then like it because of the limitations in the past and that the extension was removed from the DSC side, is it then vice versa possible to, for example, I think the system root is a custom function in DSC but doesn't exist in the Bicep landscape?
Yeah, it doesn't make sense in Bicep. So the expectation is that those functions will eventually get supported.
Okay.
Because it's going to call into DSC to resolve it. So basically, DSC will get the values that have been resolved. So any kind of nested expressions should be processed by Bicep before it hands it off to the DSC extension for Bicep to return the result.
Exactly right.
I mean, the thing that's kind of nice between both Bicep and DSC is the underlying syntax is JSON, right? So that's easily understood and the limitations are fixed. So it's easy to go between the two in that sense.
True.
All right. I think that is what the main things are. I guess the only thing else I'll cover for this meeting before maybe we close, unless there's other questions. I'm not going to repeat this tomorrow in the PowerShell OpenSH community call anyways, but I'll give you guys is that tomorrow? Or is it next week? It's next week, right?
No, it's tomorrow.
Yeah, I'm looking at my calendar. It's like I got so many meetings I have to like look between them to see which meetings I have to go to. Okay. Anyways, so the thing I wanted to cover is in terms of the DSC V3.2 timeline. Here's my current expectation, and again, expectations do change because things change all the time due to priorities, partner questions, blah blah. But I'm planning to have another release probably next week. I would like to get one other thing in for that, but I'm not going to hold it for that thing. So if certain PRs don't get merged by then I'll wait for the next one. But my expectation is that we'll have a preview next week. We'll probably have at least one more preview in, let's say, hopefully early March. And then maybe a RC late March, early April timeframe, depending on how things, feedback and stuff like that. And by the way, typically we do not have new features in an RC. An RC should just be bug fixes. And then based on the feedback of the release candidate, which is what the RC is, then we would GA. So I'm hoping that we'll get a GA sometime in May, is my guess, late April, May kind of timeframe. And again, we're not being date driven here, we're being quality driven. So if things come up, then things will shift. But at this point, we're kind of locking down on what features we really want to commit for 3.2, and basically everything else is 3.3 and above. So that's how things are laying out right now. Yep, I know, Mikey, you're working hard on that, and some of it will get in and some of it will not get in. All right. With that said,
Steve, I had a question actually. I saw the investments for 2026. Can you tell something about the Python adapter?
So yes, so just so you know, I'm going to talk about that whole blog post in detail tomorrow. So I'm not going. I'll only talk about the DSC part, which is you're asking about the Python adapter. Is that the one?
True. That's the one.
Okay. So basically, I'm the engineering manager for both DSC and PowerShell. So obviously, I love PowerShell, but I also recognize that PowerShell isn't maybe appropriate or what people will use in all environments. And particularly on Linux systems, we expect that there's probably more Python being deployed than PowerShell. Perhaps not within Azure for Microsoft first-party teams, but certainly for probably customers and other outside of Azure and Microsoft. So, and Gijs has been involved in some of this conversation as well as Thomas Neto and some other folks. And basically, we are in process of developing a Python adapter, just like how we have the PowerShell adapter. So the idea is that similar to like the PowerShell adapter, where you can write like a PowerShell script-based resource as a PowerShell class, and you don't have to know too much about DSC itself. And DSC knows how to, the adapter knows how to transform inputs and outputs from DSC into what the PowerShell class needs, and then the result gets transformed back into JSON for DSC. We would do the same for Python, right? So the idea is that if you're a Python developer or have an enterprise that uses Python, or small business, whatever the case may be, you could also perhaps more quickly write DSC V3 resources for your environment, for your line of business apps, or whatever the case may be in Python. You can still do it in PowerShell, and not have to worry about building a whole executable that adheres to what I still think is a relatively simple contract. But again, we want to make it even simpler for that type of ecosystem. So that that preview of that adapter probably may or may not be in 3.2. I'll put it that way. Like there's still a bunch of work that needs to be done, but it's definitely targeted for 3.3 for sure. So, and then we'll look at other. Well, this is where I'm going to get ahead of myself. One of the things that we as a team and as a DSC working group have talked about is this idea of an RDK, a resource development kit. So, we would definitely target some of the more popular languages that we believe we'll use. So, for example, C# is an obvious one, where in the C# case, for example, maybe you just add some attributes to your existing code, and those can become DSC resources. I'm hoping that we can maybe start more concrete discussions about that on, let's say, the second half of this calendar year. When that ships, I have no idea. It's too far in the future for me to say for sure, and I don't want to break any promises.
Don't spoil too much,
limited
Steve.
people. What's that?
Don't spoil too much.
Yeah. All right. Well, we'll keep some surprises for the future. How's that? I think that's pretty much it. Any other questions or comments from folks, or topics you want to be covered here? Otherwise, we can close and simply sync up again in about 6 weeks. I think this is every 6 weeks, I think.
Andy, can you maybe post in the link to the GitHub page for the bicep types?
I did. I'll reply to it and ping you on it.
Oops, missed it. I can see it.
Got it. Cool.
And Andy, can you work with Jason to create the AKMS link for getting the extension so you don't have to worry about that long URL?
Yes. You mean like the one that goes into the bicep config or the GitHub? We will need to test and see if that works.
The config, I'm hoping that bicep will allow for a redirect. Otherwise, that'd be a problem.
We'll test it.
Right.
Yeah.
Andy, if you reach out to Sean, he can do that
support
for you. Yeah, Andy, if you reach out to Sean, he can do that for you in about 5 minutes.
That part I'm not worried about.
Like 5 seconds.
The bicep side where it does the resolution, because I've already run into weird networking issues with that we don't need to get into.
All right. In that case, that might be something we'll have to bring back to the bicep team to have them fixed so that we can actually use the link. Okay. Anyway, we'll take that offline.
One more question, actually. Andy, is the extension going to be published to the official OC registry?
That's my plan when we get it to like a more production state rather than just this demo. Mostly, to me, that means better versions and like more dynamic typing. But that is the eventual plan.
Right.
The other thing, Bicep is working on supporting ORAS and not just like Azure Container Registry, which means that I could actually just publish it like against a GitHub repository and get it updated more easily. There's lots of avenues open to us right now, but it was for reasons a pain in the butt, but there is at least a place that it can be restored from right now with that ACR instance.
Okay. I'll shut up now.
No, don't ever.
No, it's a great question. I want to do that. I want to do exactly that.
I have no problem turning this into the Heist community call. All right. If there's nothing else, and I'm not trying to close, but we don't have to hang around here if there isn't anything else to talk about.
I might just tell Heist that I'm totally willing to take PRs to that project as well when it comes to improving it, as well as the extension itself that is built out of DSC. So if you want to start playing with it, let me know.
I'll take a look.
All right. Well, thanks, everyone. We'll conclude this call and look forward to seeing everyone at the next one, and also the PowerShell OpenSSH one tomorrow, if you can make that time.
Have a good one.
All right. Bye.
Bye.